Hello and welcome to our second Advent of Code movie. In our first movie, we had a brief introduction to what Advent of Code was all about and looked at how you set up and get an account so that you can participate in all the different challenges. In this second movie, we're going to have a quick look at one of the problems and see how you go about tackling an Advent of Code programming challenge. I thought for this first movie it would make sense to go right back to the start and look at the very first challenge, which came out on the 1st of December 2015. So to do that, if you log on to your Advent of Code account and then click on the events link at the top, you'll see all the years listed. If you go down to the bottom, 2015, click on that, you'll see the 25 challenges from 2015. Let's click on day one at the bottom. Here we go, it's called Day One, Not Quite Lisp. The first part of the description you can see here basically sets the story for this year's Advent of Code, or for 2015's Advent of Code. And it's about Santa needing to collect 50 stars in order to power his weather machine's snow function. Then we get into the actual puzzle for day one. Here's an easy puzzle to warm you up. Santa is trying to deliver presents in a large apartment building, but he can't find the right floor. The directions he got are a little confusing. He starts on the ground floor, floor 0, and then follows the instructions one character at a time. An opening parenthesis, that's a bracket, means he should go up one floor, and a closing parenthesis, that's a closed bracket, means he should go down one floor. The apartment building is very tall and the basement is very deep. He will never find the top or bottom floors. And now it gives us some examples. So we know from what we've read so far that our puzzle is going to be a series of brackets, and as you can see at the bottom here, we need to work out what floor do the instructions take Santa to. Here's this first example here. We've got an open bracket, closed bracket, and it tells us that that will result in Santa being on floor 0, which makes sense. He's gone up a floor, he's gone up another floor, and then he's gone down a floor and down a floor. So up 2 floors, down 2 floors, you'll be back where you started, floor 0. And that's the same as doing it this way. Go up a floor, go down a floor. Go up a floor, go down a floor. Back where you started. So look at the next example. 3 open brackets. So that's going up 3 floors. We'll be on floor 3. Easy. Equally, you could do it this way by going up, down, blah, 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 until you get to floor 3. These examples can be quite useful, so we're going to come back to those in a minute. But let's have a look at the instructions we actually need to solve. And you can do that here. You see it says, to begin, get your puzzle input. So if we click on that link, wow, that's a lot of brackets. Okay, now we understand why we need a computer program to solve this. If we look at the examples here, they're really easy to kind of do in our head. And even these ones at the bottom, we could probably do very quickly with a pen and paper. But this number, we'd need a very big piece of paper to do those on, and it would take a long time and be really difficult to not get lost or make a mistake. But at each step in the program, each character we encounter, each open or closed bracket, we're just doing the same thing. It's a repeatable process. And that's where computer programs are really good at helping us. So writing a program to solve this should be really simple, in fact. We need to save our puzzle input because the program we're going to create is going to have to load that in to process it. There are a few ways of doing it. I think the easiest way, if you're using a browser like Chrome, is to right-click and click on Save As. I've already created a folder on my computer called AOC 2015 to save all my solutions and the puzzle inputs in. Now I don't want to call it input.txt because otherwise every days would be called the same thing. I want to make sure I can easily find the input data for each day's challenge. So I'm going to call it day 1 underscore input. It'll be called .txt and save there. And I can use that in my program. While we're saving things, I'm also going to save one of these examples in a text file as well. And I can use that to test my program. All of these brackets might take a while to process. And if my program's not working correctly, I don't want to have to wait a long time to see that it's not working correctly. I'll just want to try my program out first with a small data input. So I'm just going to copy this one here, the set of brackets I've picked, and then I'm going to save that into a text file. Because I'm using an Apple Mac, I'm going to use the text edit program. So I'll paste my brackets in there, and then I'll save that. I'm going to save it in the same place, and I'm going to call that day1_test1. And you can see it's going to be saved with a .txt extension because it's a text file as well. There we go. Now we need to actually start writing our program. In all of these movies, I'm going to be using the Python programming language to solve the advent of code puzzles. You can use any language you like. Remember, all you do at the end is input the answer from the program. You don't actually have to submit the program itself, so you can use any programming language you like. Some people even start some of the earlier challenges in an advent of code season using Scratch, but we're going to use Python, and we're going to use the Python editor Thonny in order to write our programs. So here's Thonny here. As you may know, you start typing your text here, and there's also a little REPL console at the bottom. So let's get started with our program. Remember, we've saved our puzzle input data as a file. So the first thing we're going to need to do is to load that in. What are we going to do with it then, though? Well, what is our puzzle input? Basically, it's a list of brackets, either open brackets or closed brackets. So as it's a list, I think it makes sense, at least initially, to store that as a list. So the first thing I'm going to do in my program is create an empty list called instructions, because these are Santa's instructions. And remember, in Python, to create an empty list, we just use the open and close square brackets. Now I need to deal with my file. There are a number of ways you can load files into a Python program. This is the way I like to do it. Basically, I open the file and then read the file one line at a time. So I'm going to say with, and then I'm going to use Python's open function and give it the name of our data, which is day1_input.text. No, actually, I'm not going to do that because our input data is actually really long. So I'm going to start with our test data, because that's much shorter. So I'm going to load that file in, and I'm going to call it the name file. I could have called it anything, but as it's a file, I think it makes sense to call it file. Then I'm going to take each line in that file. So again, I'm going to say for, and I'm going to use the name line, but again, I could have called it anything. For line in file, what am I going to do? Well, one thing we do need to do is to get rid of any hidden characters that we might not see in our file. And that includes things like the new line character. The new line character in a text document tells the application that's displaying it to create a new blank line. So we need to get rid of those things in case they cause us problems. And that's really easy to do. So I'm going to take my line and I'm going to use Python's strip function on it, and then just save it back as itself. So I'm going to strip everything off of the line and save it back into line. Finally, I need to deal with each character in every line. And this is the same kind of format we can see already. So this time I'm going to say for C, for the character, for C in line, what do I want to do? Well, I want to add it, I want to append it to my instructions lists. So I can say instructions.append C. That looks like it will work. Maybe before we do anything else, we can just check that we're successfully reading in our file. So I'm going to print my instructions list out. Maybe I've got a bug, let's find out. In Python, to run the program, we click on the green arrow, and now it's going to come up and ask me to give my program a name. So to keep everything consistent, I'm going to call it day1_part1, because remember, this is the first part of the problem. Thonny will automatically give it the .py extension. And there we go. And that's run and produced what we expected to see. So it's printed out all the brackets that we've read in from the file. Great. So we know that that part of our program is working now. Let's move on to actually solving the challenge that we have to. So first thing I'm going to do is I'm going to comment out that line, so I don't need to see that. And then I need to think about what we should do with each of these brackets. Well, what's the problem we're trying to solve? We need to work out which floor Santa will end up on after he's followed all the instructions. So we'll create a variable to keep track of the floors. I'm going to call it floor, and we know that at the start Santa starts on floor 0, so I'll set that to floor 0 straight away. Now we need some Python to actually do the processing. So I think what we're going to use is yet another for loop, because this time we want to iterate over all the different instructions that we've stored in our list. So we could say for I in instructions, get the colon. What are we going to do? Well, first of all, we need to look and see what the first instruction was and take an action depending on whether it was an open bracket, in which case we'll go up a floor, or a closed bracket, in which case we'll go down a floor. So we could say if I equals, because we're checking whether something is equal to something else, so that's two equal signs in Python, it's equal to an open bracket, then what do we need to do? Well, we need to make floor 1 bigger. So we can say floor plus equals 1, which is Python shorthand for saying add 1 to the floor variable. What next? Well, next we could check to see if our instruction is a closed bracket, and if it is, this time we need to take 1 away from floor. And let's just be really cautious, and we'll have an else in. So if it's anything else, if the instruction we read in from our list isn't an open bracket or a closed bracket, then let's print out the word error, because we shouldn't be getting anything else. And if we did find some other character in our program, it would be good that we could know about that. That might help explain why we weren't getting the answer we wanted. And then finally, we need to see what the floor variable has ended up being when we finished all our processing. We've gone through all of our loops. So let's just run that now based on our test data again, the one we see here. Great, and we've got the answer 3, which is what we expect. We know from the example that this should come out as the number 3. Okay, that's great. Now, we've got more than one example we could test here, but I'm quite confident that this is working right. So it's probably worth trying our program with the real data. So I'm going to change the file we load in to make it our input file and run our program again. And this time it's come out with the answer 74. It says that Santa ends up on floor 74 after it's processed all of those open and closed brackets. Well, let's see if that's the right answer. Let's go back to our puzzle input here and type in 74. Let's submit and see if we're right. That's the right answer. You're 1 gold star closer to powering the weather machine. And now we can continue on to part 2. Let's see what part 2 of the puzzle is. Normally, they take what you had to do in the first part and make it a bit harder. Although sometimes they can be a completely different puzzle altogether in a way. Let's have a look and see. Okay, part 2. Now, given the same instructions, find the position of the first character that causes him to enter the basement, which is floor number -1. The first character in the instructions has position 1, the second character has position 2, and so on. So, for example, this input file of just a single closed bracket, basically go down 1 floor, would cause Santa to enter the basement, which is floor -1, 0 minus 1 is -1, at position 1. In this example, where we've got an open bracket, so he goes up a floor, a closed bracket, down a floor, so that's taking him up to 1 and down to 0, and then up to 1 and down to 0 again, and then down again. So that last character, position 5, is the one that takes him to the basement. Okay, I think that's okay, and we can probably use most of the code we've already written for part 1 in order to solve this one. Let's go back to our program. What I like to do now is to keep a separate program for each part of the challenge. That makes it really easy if you end up trying to solve part 2, mess up your first program, decide, this approach isn't working, I need to go back to the start. It's much easier to be able to go back to your working version of the part 1 solution. So what I'm going to do, File, Save As, and just save this instead of being part 1. I'm going to call it part2.py. There we go. Right. So how do we need to modify this? Well, I don't think we need to change it too much. We still need to go all the way through the program, but this time we only need to go as far as when Santa ends up on floor -1. So in fact, we could use all of this same code, but every time we use one of the new instructions, we'll just check to see if we're on floor -1. So we could say if floor equals -1, what do we want to do? Well, we just want to print out that character number. Okay, so we'll need something to keep track of the character numbers as we go through. Let's have another variable here, and we can call that, why don't we call that character number? And we were told in our instructions that the first character in the instructions has position number 1. So we start off with character number being number 1. And then every time we go through our loop of reading an instruction, we'll need to increment or add 1 to that number. So we can say character number plus equals 1. And then going back to our if loop here, if the floor equals -1, we'll just print out our character number. And so we don't really need to print the floor at the end of it now, do we? So we can probably comment that out. Again, we could test this with some of the examples we have, but I think I'm quite confident that our program's working well, and the logic of this is fairly simple. So let's just run this and see if we've got it right here. Well, it looks like, interestingly, it looks like our set of instructions has Santa visit the basement more than once. But our puzzle asked us for the character that causes Santa to first enter the basement. So that will be the first one that's printed out here. So I'm just going to copy that, make sure I don't mistype it, paste that into the answer box, and let's see if we got things right. Oh, that's not the right answer. My answer is too high. Oh dear, right. Okay, so now that's useful though. It's told us one thing, that our answer is too high. Let's go back to our program and see if we can work out what's gone on with it. Okay, so maybe I was overconfident in saying we didn't need to use some of the examples. Let's have a look and see. Let's do some more testing to see what's going on with our program. So let's take this example at the end here. Take that sequence of brackets. And we'll just save that as another text file. So let's save that as a1 underscore test2.txt. Okay, and now let's try our program with that instead of the test input, because we know the answer should be 5. Oh, well, it didn't print out anything. That's interesting. Let's uncomment out the line that prints at the end. Okay, -1. So that's printed out the floor number that we end up on once our program's finished, and it is in the basement. So why didn't our program print out the instruction number? Well, one reason might be that our program finished before we entered the situation whereby the floor number was -1. Now let's just add in another line at the end here, shall we? So see, before we change our character number, let's print out, well, let's print everything. Let's print our instruction, I. let's print the character number, that is, and we'll print out the floor. So every time we go through the loop, when we finish doing all our stuff, our processing, we'll just print out the state of all our variables. Okay, so let's have a look. So we read in the first character, which was an open bracket. Our character number was 1, which is correct because it was the first instruction. And we ended up on floor number 1. And that's right, because we went up a floor. The second one, we had a closed bracket, so that was the second character, and we went down a floor back to 0. Line 3, we had another open bracket, so we went up a floor, and that was character number 3, correct. And then on the fourth one, we went down again, back to 0, and on the fifth, we went to the basement. So the answer was 5, but why didn't our program print? Now if you think about it, I can see why that's happened now. When we're printing out here, that's after all our processing has happened, after we've examined what the character is and changed our floor variable accordingly. But when we're doing our test to see if the floor variable is -1, we're doing that before all this has happened. So in the case of our test program, our program's finished before we're actually changing the floor to -1, which is after this has happened. So I think if we move our test to also be at the end of our program rather than the start, let's run that now. And now you can see we're printing out 5 correctly. So we could almost comment out the line we added, our debug line there, and we'll print out the floor number, and we should just get the answer we need now, which is 5. Great, okay. So that implies that the answer we first submitted, we were just off by 1. And that's a really common error in Advent of Code, actually. You find that because you're counting from 1 instead of 0, or you've got something the wrong place in the loop, that your answer is actually just off by 1. So let's run it with our actual input data now. There you go, see, and that is just 1 less than we entered before. So let's put that in, submit it. Yeah, and that was the right answer. And so now we've got 2 gold stars. If we go back to our calendar for this year, we can see we've coloured in 1 line of our Christmas tree and we've got 2 gold stars. So that's the first challenge from the 2015 Advent of Code completed. Before we finish, let's just have a quick look at our code, because there are some key things in here that we'll find that we'll use in lots of other Advent of Code challenges. First of all, this idea at the top here of taking data from a file. We use the open function to open our file and then process it line by line. And that's a really good way of taking in our data and doing stuff with it. In this first challenge, we didn't really have to do much. We just had to read the character from every line, and we chose to load it into a list. But often you'll find that that's the best way of dealing with lots of data that you get in Advent of Code challenges. And then further on, we used some test data to check our program when it wasn't working, rather than try and run it on a big load of data to start off with. And having the examples in the actual problem itself, as we saw in Advent 1, is really common. The Advent of Code challenges will always give you examples, and you should definitely use those to try and test your program, particularly if it isn't working. And then when our program wasn't working, we used these debug statements. We added in print statements to print out the states of various variables as our program was processing the data to see what was going on. And imagine if we'd been doing that with our full data set, this console here would have been filled up with lots and lots of lines, and it would have been very difficult to follow what was going on. But by taking one of the simple examples, we just had 5 steps to follow, and we very quickly could see what was the problem with our program. I hope you enjoyed this movie. Stay tuned for the next Advent of Code movie, where we'll tackle another challenge from one of the years gone by. Bye bye everyone.